We are looking at R.D. Sharma solution class 12. This is chapter 19. We are taking the multiple choice questions of indefinite integrals. Now sine to the power 8, sine raise 8, x minus cos raise 8x divided by 1 minus 2 sine square x cos square x. Now this is equal to the question I am just writing, a sine twice of x plus a constant of integration. So we need to find out the sine 2x, anything which is in front of sine 2x or a coefficient of sine 2x, you can say, that will be your correct answer. Now this always we know a square minus b square. Let's write this sine raise 8 as sine raise 4x square and cos raise 4x square. So now this has become a squared minus b squared. So a square minus b square is a minus b into a plus b. This you already know. We will write this. I'm just doing the numerator right now. So a square minus b square is a minus b into a plus b. So sine raise 4 plus cos raise 4x and sine raise 4x minus cos raise 4x. We have not finished yet because we still have sine raise 4x minus cos raise 4x. So this can be written as sine square x whole square minus cos square x whole square. Again, using the formula, we will make it as a minus b into a plus b. In this case, a is sine square x, b is cos square x. So when you write this formula, this is for the sine raise 4x minus cos raise 4x. You know that sine square x plus cos square x is equal to 1, so we can just eliminate it. Now first is this one, second is this one. Now let's come to the denominator. We have sine square x plus cos square x equals to 1. So most of the time, the students are tempted to write sine square x plus cos square x for 1. So numerator has been done, I am doing the denominator right now. Minus 2 sine square x cos square x. But the problem is that even if you do this, you are not going to get anything because it is if you want to make a formula, it has to be a minus b whole square, that is a square plus b square minus 2ab. So you ought to have sine raise 4x here. Alright, so I hope that this kind of approach will not benefit us because a square plus b square minus 2ab won't work here. So you ought to have sine square x plus cos square x whole square. So in place of 1, write sine square x plus cos square x whole square. Then you have minus 2 sine square x cos square x already. Now you can take a and b as sine square x and b square x respectively. A and b respectively. Now let's open this. A plus b whole square is a square plus b square plus 2ab. So sine raise 4x plus cos raise 4x plus 2 into sine square x cos square x will come. Then you have this minus 2 sine square x cos square x also. This will get cancelled. So then the denominator only sine raise 4x plus cos raise 4x will come. Now I am writing numerator divided by denominator as the ratio. So this numerator has come, which I am writing right now. Denominator we just did, and this has come as sine raise 4x plus cos raise 4x. Fortunately, the numerator and denominator has the same expression which you can cancel. So we just have to deal with sine square x minus cos square x. But incidentally, cos square x minus sine square x is cos 2x. Let me write it here. Cos 2x is cos square x minus sine square x. The only difference what you see here is the positions of the sine square x and cos square x that we can change after taking negative outside. So when we take negative outside, the numerator will become cos 2x because it will be cos square x minus sine square x. What is cos 2x integration? It will be, negative is already there. It will be sine 2x, then you have to differentiate 2x, 2 will come, it will go in the denominator. So this will be sine 2x divided by 2 with a negative plus constant of integration. So we have completed the integration. Let's equate it with the question. A sine 2x plus constant of integration. What you see here, minus 1 by 2 is equating to a sine 2x is already there, c is already there. So from here, a is equal to negative half, which is the first option here. So this is how you're going to do this. It's a good question. And a equals to negative half is the correct answer in this case. Next one is x minus 1 into e raised minus x. So you have two different expressions and an integration. So we'll follow the integration rule here. The product integration rule, what does it mean? We'll apply the ILATE. ILATE is exponential is in the last. So we'll take x minus 1 as the first function, e raised minus x as the second function. So applying the formula x minus 1 into e raised minus x dx. So we need to apply that formula. First will be x minus 1, second will be e raised minus x. So x minus 1 will come in front, integration of e raised minus x dx minus integration of e raised minus x dx will already be there. And then the differentiation of x minus 1 will be done. Then all these two components will be multiplied and then integration will be done again. You know that formula already. So we have x minus 1 here, e raised minus x. Integration of e raised minus x is e raised minus x. But minus x will be differentiated, negative 1 will come. That will go in the denominator. You can always keep it in the numerator also. d by dx of x minus 1 is 1. E raised minus x dx is already we have done negative e raised minus x. So I can change this outside negative as positive. E raised minus x dx will retain here. So we need to integrate e raised minus x again. That will again give you negative e raised minus x. So we have minus x minus 1 e raised minus x plus a constant of integration with e raised minus x with minus 1 here. So just change the sign here. It's better to change the sign here. So what is the final result? You can take e raised minus x common and this minus x plus 1, because you multiply minus with x minus 1, it will be negative x plus 1 and then it will be a negative 1 also inside. 1 gets cancelled, only negative x will remain. So the final result will be negative x into e raised minus x plus a constant of integration. So let me write it here. You can just see now which one of these options are correct or which one is matching. So negative x into e raised minus x is matching here. And that's your final answer. So this question is a different question because this is a simple integration of two values, two expressions. Now 2 raised 1 by x square dx, and it is equated to k into 2 raised 1 by x plus constant of integration. So the integration on the left, right is the result of that one. That means we'll find out the result and we'll try to equate it with k into 2 raised 1 by x. Whatever is coming in front of 2 raised 1 by x, that will be our answer. So 1 by x can give you 1 by x square after differentiation. So when you put t equals to 1 by x and you happen to differentiate it, dt by dx will be equal to negative 1 by x square. That means this negative, if you bring on the left, negative dt will be dx by x square. So this dx by x square we got just now after putting t equals to 1 by x. So this integration whole will be like this, integration of 2 raised 1 by x. What is 2 raised 1 by x? 1 by x has been taken as t. So 2 raised t, negative dt, so negative I am taking outside, dt remains inside. So a raised x integration you know already. That is what we have to do here. A raised x divided by log a. Please remember the log has base e in this case. So wherever you have x, put t. Wherever you have a, put 2. Now this formula can be changed and the values can be put here. So 2 raised t by log base e2 plus a constant of integration. Now t was taken as 1 by x, so negative 2 divided by raised to 1 by x, or negative 1 by log 2. Please remember base is e plus a constant of integration. Now you have to equate it on the right. If you see in the question, you need to equate it with k into 2 raised 1 by x plus constant of integration. So let me write this one here so that I can equate it directly. K equals k dot 2 raised 1 by x, c is there, 2 raised 1 by x is also there. So the k has become negative 1 by log base e2. So k has come as negative 1 by log 2, which is this one. Okay, now this is how you are going to do this. Well, MCQ doesn't want you to write and show, but this can come in any question, not only in MCQ. 1 by 1 plus 10x. So this question has already been done in integration. If you just revert back, go back and see the exercises from 1 to 32, you'll find this question already been done, but we'll do it here just to recall. 10x will be sin x by cos x. So 1 plus sin x by cos x will come. Now take this, I'm doing the denominator. 1 remains upstairs. So cos x plus sin x, denominator will be cos x, that will go up. So you can bring this or take this cos x and put it on the top. So this integration has become like this, integration of cos x divided by cos x plus sin x. Now what is this step we are going to do? We need to cancel it, of course. So just multiply 2 and 2. We multiply the numerator denominator by 2. This 2 cos x can be written as, see, I am writing cos x and cos x. We ought to have a sin x here, so just add a sin x and then subtract a sin x. So this sin x plus cos x has come, which is actually the denominator, and cos x minus sin x has also come. So the integration will become like this. Half is already there. 2 cos x we have written like this, so I'm just writing that cos x plus sin x, and then second one will be, I'm just swapping these two terms, cos x minus sin x I'm writing. So cos x minus sin x in this case. In the denominator you have cos x plus sin x. So this you can separate this out in this step also, but rather than doing this, write this and then in next step you can separate them out. So I'm just separating these two terms. Half remains like that. I'm going to multiply this half in the later part. Let's do the separation first. So first part will be cos x plus sin x divided by cos x plus sin x. The second part will be cos x minus sin x divided by cos x plus sin x. So this cos x minus sin x divided by cos x plus sin x will come, and dx is always there. Okay, even if I skip dx, don't worry, because you know that dx is already there. Integration is with respect to something. So the integration, see, this gets cancelled, only one will come. So you are going to integrate dx only, which is only x plus. Now this cos x plus sin x can be taken as t. When you differentiate it, the numerator will come. We have done it already, so just to recall, t equals to cos x plus sin x. When you differentiate this dt by dx, cos x will be negative sin x will be cos x. So added with cos x minus sin x will come. So this numerator is actually, when you multiply it with dx, it will be simply dt, and the denominator will be t. So actually you are integrating dt by t, which will come as log t. You already know that. X plus log t will come with a base e, and this t will always come in the modulus. But t already know, we have know what we have taken, sin x plus cos x. So you can write directly here, x plus log sin x plus cos x plus constant of integration, multiply it with a half. So just multiply it. You don't have to multiply half with c. Just multiply half here. And now equate which one of these is correct answer. The last one is matching exactly what we have completed just now. Now this is how this will be dealt with, and you have to write, if it doesn't come in the MCQ, you have to write this. Okay, all this mathematics, all this putting equals to since, and therefore all this you have to do. Now this modulus x whole cube, I hope you have a very fair idea about modulus x. Modulus x is if x is greater than or equal to 0, that is x is a positive number, 0, 1, 2, 3, 99, 99,000 like that. So it will be x. But if it is less than 0, that is negative 2, negative 99, you have to put a negative to make it as a positive. That's why you have to have a negative x, because the modulus x will always give you the positive quadrant. The values will always be positive. So if x is less than 0, you ought to have a negative in front of that. That is why for x less than 0, it is negative x, because you have to have a positive value. You cannot have a negative value. So there will be two cases here. First case will be when x is greater than or equal to 0. So this modulus x cube, x will be x only. X is greater than or equal to 0. There is no negative involved. So it will be modulus x will be x only from here. So it will be x cube dx. So this will be x raised 4 by 4 plus constant of integration. It's a straightforward integration. In the second case, this will be x is less than 0. When x is less than 0, the modulus x will give you negative x, because x is less than 0, as I shown you earlier. You can consider like this, negative is x into negative x into negative x. So it will be negative x cube. Negative you can take outside, and you just have to integrate x cube dx. So this will be x raised 4 divided by 4 with a negative sign here. So x is, the first case gives you a positive, same content, x raised 4 by 4, but it is positive in the first case, it is negative in the second case. So you are getting two values here, and these both values are being given in the MCQs also. The first one and the second one, they both are coming, the first and the third one. So you will say that it is none of these. So let me show it to you. This is how you're going to go about it. And if you want to write, it is not in the MCQ question, it comes in the actual question, then you have to write like this. So sec root x by root x, cos root x by root x, tan root by x by root x, cos sin root x by root x, all questions will be done like this, which I'm showing you right now. In the previous exercise, that is the way VSAQ exercise, we have done 3 questions like this, one by one subsequently. So you just take t equals to root x. Oh, why I have written root t, I don't know. But it is actually t equals to root x. I'll just change it. Actually, differentiating anything with a root or root x or root t or root p, it will be 1 by this, say 1 by 2 came, and this will be 1 by twice of root x. This is differentiation. Let me change this t to x. It will create some confusion. So I'm changing all the t's to the x. I wouldn't have done it to begin with. So 1 by 2 root x has come. Now this dx by root x is already there. So dx can be brought on the right. So dx by root x is actually twice of dt. So we have 2 dt here. Dx by root x is already there in the question. So this integration will become like this. This integration will be cos root x we have taken as t. So cos t dx by root x is twice of dt. So 2 you can bring there, dt here. Cos t has a simple integration. You already know that sin t. 2 is already there. plus constant of integration root t, this t is root x. So replace it now. 2 sine root x plus a constant of integration. Now this whole is the correct answer. Which one of this is the correct one? The D one. 2 sine root x plus c. So if it doesn't come in your this thing, you can means MCQ, you can solve it. Now this question, if you see, it seems something else. But if you know trigonometry well, 1 plus cot square x is cosec square x. This is a direct result. Sec square theta is 1 plus tan square theta. Cosec square theta is 1 plus cos square theta. Cot square theta. Cot, it is not cos, it is cot. So we'll use that. 1 plus cot square theta, you can write directly as cosec square theta. Erase x is outside, and the inside one we'll write like that. That 1 plus cot square theta, we'll write it as cosec square theta, and this cot theta will be negative. But I will not write it like this, because I can perceive or I can anticipate what is going to come. I will write this cot x first, because cosec square x should be placed first, cot x later. That means you ought to take a negative outside. The question will come as cosec square x minus cot x, but we have to have a cot x minus cosec square. You'll just see now. So I've taken a negative outside which goes beyond your integration sign. So just have to deal with this one inside one. Erase x, fx plus f dash x. If at all it comes like this, if it matches, erase x, fx is the direct answer. If you take fx equals to cot x, you differentiate it, f dash x will be what? Minus cosec square x. That's what we wanted. Fx is cot x, f dash x is negative cosec square x. So as I told you, the direct result will be erase x into fx. So what is fx here? Minus cosec cot x. Fx was taken as cot x. So erase x into fx. The only difference here is negative is in front of integration, which you have to add here. Then you can see which one is the correct answer. Otherwise, erase x, cot x will be, may be the answer, but it is not. So negative erase x, cot x is the correct answer, which is our second one. We have applied the formula here, or the result direct here. This question we are going to take in the next discussion. Till then, thank you so much. Have a good one.